Good morning, students. Today we are going to discuss the surface area volume this chapter. And in this chapter we are going to discuss the exercise 1, that is 13.1. In this exercise we are going to use two formulas of cuboid and two formulas of cube. The total surface area and the curved surface area of a cuboid and total surface area and a curved surface area of a cube. Let us see the two sums that we are going to discuss today. The first sum, that is question number 3. The floor of a rectangular hall has a perimeter of 250 meter. If the cost of painting the four walls at the rate of rupees 10 per meter square is 15,000 rupees, find the height of the wall. So the perimeter is given of a floor, that is length and breadth is provided, but the height of the cuboid or the rectangular hall is not provided. We have to find the height. So this is the diagram. The top of the hall and the floor of the hall will be excluded as area of the floor is to be found out. So let us see in the solution. Let the length, breadth and height of the rectangular hall be L meter, B meter and H meter respectively. In the question, perimeter of a floor of the hall is given. So the perimeter of a rectangle is always 2 into L plus B, which is 250 meter equals to 2 into L plus B. If we subject L plus B, we will get 250 by 2, that is 125 meter. This is our first equation and this L plus B will be needed further in the sum. Now area of the four wall is provided. The area of the four wall, the costing of the painting of such four wall is given. So either we can use CSA, that is curved surface area volume, curved surface area formula, or we can use the area of a cuboid and subtract the top and the bottom, that is the floor and the top, the ceiling of the rectangular hall or the walls. So the area of a cuboid is 2 into LB plus BH plus LH. Area of the floor is LB and area of the top is LB, as both of them are rectangles. So we will subtract 2 times LB from the area of the cuboid. We will get 2LB plus 2BH plus 2LH minus 2LB. So the first 2LB and the minus 2LB will cancel each other off and we will get 2LH plus 2LB. If we take common, then we will get 2H into L plus B, which is equals to 2H into L plus B. Now L plus B, we already know the value of L plus B is equals to 125 from equation 1. We will substitute the value. So we will get 250 into H meter square. This is the area of the wall. Now area of the four wall is 250 meters, 250 H meter square. Now in the question, the costing of painting of the walls is given. So cost of painting per meter square is rupees 10. Cost of painting of 250 H meter square will be 10 into 250 H. Now this 10 into 250 H is given in the question as 15,000 rupees. So according to the question, we will get 15,000 is equals to 250 into 250 H into 10. If we subject H, we will get 15,000 divided by 2,500, which is equals to H. H is equals to 6. So we will get the value of H or the height of the hall as 6. So in this question, the last part, that is the cost, is given, but the initial part where L, B and H is to be given, this is not provided. So we have to assume few things and use the given content in the question and then proceed forward. At the end, we will equate the cost that is given in the question, which is 15,000 rupees, to the assumed cost that we can get if LBH amongst this one is not provided. So this is how we can do questions like this. Now let us see another example. Question number 4. In question number 4, it says the paint in a certain container is sufficient to paint an area equal to 9.375 meters square. How many bricks of dimension 22.5 centimeter into 10 centimeter into 7.5 centimeter can be painted out of this container? That means dimension of one brick is given, and from the container the total area that can be painted is provided. So it can be easily found out. Since one dimension of the brick is given, we can assume that n number of bricks are used with this dimension. The dimension that is given, that is 22 into 10 into 7.5. This should be equal to the total area that is given. But now here one more thing that we have to see is the area that is given is in meter square, whereas the dimension of the brick is in centimeter. So either we have to convert the meter into centimeter or centimeter into meter, so that until and unless the units are same, we cannot cancel each other. So we have to make the units same. So let us see how to do the sum. Now the dimension of a brick is given in the figure. So how to find the number of bricks? The number of bricks that can be painted out of the container should be equal to the area that can be painted by the container by the surface area of the brick. Surface area means the total surface area. That formula we will use. Now area that can be painted in a container is given in meter square. It is easy for us to change the meter into centimeter to avoid points. So we will change the meter into centimeter. Here the area that is painted is 9.375 meters square. We know 1 meter is equals to 100 centimeter. So 1 meter square is equals to 100 into 100 centimeter square. So we are multiplying by 100 square. On multiplication by 100 square, there will be 4 zeros. So the point will be jumping 4 times. So we will get 93750 meters square. This is the area that can be painted by the paint from the container, and that too the unit is centimeter square. Now the dimension of the bricks are given. We are going to use the total surface area of one brick, which is 2 into LB plus BH plus HL. On multiplying, we have to substitute the value of H, L and B from the figure. So substituting the values, we will get 2 into 22.5 into 10 plus 10 into 7.5 plus 22.5 into 7.5. All the dimension was in centimeter, so the area will also be in centimeter square. On multiplying, we will get 937.5 centimeter square. So now we have both the dimension in centimeter square, and in the previous statement or the first line of the answer, we have written number of bricks equals to the area that can be painted by the total surface area of the brick. So here is the formula: area that can be painted by the container by surface area of the brick. Both the dimensions are in centimeter square, so they will cancel each other. Centimeter square by centimeter square will cancel each other, and we will get only a numbered number. And moreover, number of bricks does not have any unit, so there will be no unit in this case. So on dividing, we will get 93750 divided by 937.5. So we will remove this point and the point will go up as 10. We can cancel each other. See, all the numbers are same, 937,500 by 9375. So it will cancel each other and we will get 100. So 100 bricks can be painted out of the container. The paint can be used. So these are the two sums, question number 3 and question number 4 of exercise 13.1. I hope this tutorial is helpful for you. Thank you.